When a pool transforms into a shallow wading area adjacent to a house footer, the house footer steel should be bonded to the pool steel. Since the pool and the house footer are in direct contact, they form a continuous conductive path. Bonding them ensures proper grounding and prevents the buildup of electrical potential between the structures. Now, let's consider a window. If a window is within 5 feet of the pool, the footing for that window is also considered to be within 5 feet and should be bonded. This is because the window and its footing are part of the structural integrity of the house, which is now in close proximity to the pool. Next, let's talk about independent columns. If an independent column holding up the lanai roof has its own footer that is within 5 feet of the pool, the column steel should also be bonded to the pool steel. The column and its footing provide a potential path for electrical current, so it is important to ensure conductivity between them and the pool. When performing any bonding, there are several additional considerations. Firstly, all bonding connections should be made in accordance with local building codes and best practices. Secondly, use a grounding conductor with a minimum size specified by the code. Thirdly, ensure that all connections are tight and secure to create a low resistance path for electrical current. It is recommended to have the bonding work inspected and approved by a qualified electrician before filling the pool. In all of the scenarios described, it is crucial to bond the steel of the pool to the steel of the nearby structures within 5 feet. This ensures proper grounding and minimizes the risk of electrical hazards. It's important to understand the principles behind bonding and grounding to ensure safety around swimming pools. The primary purpose of bonding is to create an equipotential plane, meaning that all metallic parts within and around the pool area are at the same electrical potential. This minimizes the risk of electric shock by preventing voltage differences that could cause current to flow through a person. The National Electrical Code, or NEC, provides specific requirements for bonding swimming pools in Article 680. It outlines the types of equipment that must be bonded, the methods for making bonding connections, and the required size of the bonding conductors. Some key components that need to be bonded include the pool reinforcing steel, metal fittings, metal parts of electrical equipment, and any metal within 5 feet of the pool. The bonding conductor is typically a solid copper wire, and its size is determined by the size of the circuit conductors that supply power to the pool equipment. The NEC specifies the minimum size of the bonding conductor based on the ampacity of the circuit. Bonding connections should be made using listed connectors that are suitable for direct burial in concrete. These connectors are designed to provide a reliable, low-resistance connection that will withstand the corrosive effects of the pool environment. When bonding, the pool reinforcing steel connections should be made at multiple points to ensure that the entire steel structure is effectively bonded. The NEC requires that the reinforcing steel be bonded at least 4 points, spaced evenly around the pool. For metal fittings such as ladders, handrails, and skimmers, bonding connections should be made directly to the metal part. If the fitting is made of a non-conductive material such as plastic, the bonding connection should be made to the metal mounting hardware. Electrical equipment such as pool pumps, heaters, and lights must also be bonded. The bonding connection should be made to the equipment grounding terminal, which is typically located inside the equipment enclosure. Any metal within 5 feet of the pool must be bonded, including metal fences, metal door frames, and metal window frames. This is to prevent voltage differences between these metal parts and the pool water. In addition to bonding, grounding is also an important safety measure for swimming pools. Grounding provides a path for fault current to flow back to the source, which will trip the circuit breaker and energize the circuit. The NEC requires that all electrical equipment associated with the pool be grounded. The grounding conductor is typically a green insulated wire, and it must be connected to the equipment grounding terminal in the electrical panel. Grounding electrodes, such as ground rods or ground plates, are used to provide a connection to the earth. The NEC requires that swimming pools have at least one grounding electrode, and it may require additional electrodes depending on the soil conditions. The grounding electrode must be installed in accordance with the NEC requirements. When installing electrical equipment near a swimming pool, it is important to maintain proper clearances from the water. The NEC specifies the minimum clearances for electrical equipment based on the voltage of the circuit and the type of equipment. Receptacles must be located at least 10 feet from the inside wall of the pool, unless they are GFCI protected. Lighting fixtures must be located at least 12 feet above the maximum water level of the pool. Overhead power lines must be located at least 22.5 feet above the pool. When working on electrical equipment near a swimming pool, it is important to take precautions to prevent electric shock. Always turn off the power to the circuit before working on any electrical equipment. Use insulated tools and wear rubber gloves to protect yourself from electric shock. Never work on electrical equipment when you are wet or standing in water. If you are not qualified to work on electrical equipment, hire a licensed electrician to do the work. Swimming pools can be a source of electrical hazards if they are not properly bonded and grounded. By following the NEC requirements and taking precautions when working on electrical equipment near a pool, you can help to prevent electric shock and ensure the safety of swimmers. Now let's delve deeper into the specifics of bonding the different components around a pool, starting with the pool reinforcing steel, often referred to as rebar. This steel grid embedded within the concrete shell of the pool provides structural integrity but also presents a potential path for electrical current. The NEC mandates that the rebar be bonded at a minimum of 4 points, distributed evenly around the perimeter of the pool. These connections should be made using approved bonding connectors designed for direct burial in concrete. These connectors are typically made of copper or bronze and are specifically designed to resist corrosion in the harsh pool environment. The bonding conductor, typically a solid copper wire of appropriate gauges determined by the NEC, is then connected to these connectors, forming a continuous loop around the pool's rebar structure. Moving on to metal fittings such as ladders, handrails, and skimmers, each of these components must also be individually bonded. For ladders and handrails, the bonding connection should be made directly to the metal frame of the fitting. If the fitting is made of a non-conductive material, such as plastic, the bonding connection should be made to the metal mounting hardware that secures the fitting to the pool structure. Skimmers, which are designed to remove debris from the pool surface, typically have a metal housing or frame that must be bonded. The bonding connection should be made to a designated bonding lug or terminal on the skimmer housing. Electrical equipment associated with the pool, such as pumps, filters, heaters, and lighting fixtures, requires careful attention to both bonding and grounding. Each piece of equipment should have a dedicated equipment grounding conductor, typically a green insulated wire that runs back to the electrical panel and connects to the grounding bus bar. This grounding conductor provides a low impedance path for fault current to flow back to the source, tripping the circuit breaker and energizing the circuit in the event of a ground fault. In addition to the equipment grounding conductor, the metal housing of each piece of equipment must also be bonded to the pool's bonding grid. This is typically accomplished by connecting a bonding conductor from the equipment housing to the pool's rebar bonding loop or to a dedicated bonding busbar installed near the equipment. Any metal surfaces within 5 feet of the pool, whether part of the pool's structure or adjacent to it, must also be bonded to the pool's bonding grid. This includes metal fences, metal door frames, metal window frames, and even metal furniture. The purpose of bonding these nearby metal surfaces is to eliminate any potential voltage differences between them and the pool water, reducing the risk of electric shock to swimmers. For metal fences and other large metal structures, the bonding connection should be made at multiple points to ensure that the entire structure is effectively bonded. The bonding conductor should be securely attached to the metal surface using approved bonding connectors. Grounding electrodes play a crucial role in providing a low-resistance path to earth for fault current. The NEC requires that swimming pools have at least one grounding electrode, and it may require additional electrodes depending on the soil conditions and the size of the pool. Common types of grounding electrodes include ground rods, ground plates, and underground metallic water pipes. Ground rods are typically copper-clad steel rods that are driven into the ground to a depth of at least 8 feet. Ground plates are copper plates that are buried in the ground. Underground metallic water pipes can also be used as grounding electrodes, provided that they are in direct contact with the earth for at least 10 feet. The grounding electrode conductor, typically a bare copper wire, connects the grounding electrode to the grounding busbar in the electrical panel. The size of the grounding electrode conductor is determined by the size of the service entrance conductors. Maintaining proper clearances from the pool water is essential for preventing electrical hazards. The NEC specifies minimum clearances for electrical equipment based on the voltage of the circuit and the type of equipment. Receptacles, or electrical outlets, must be located at least 10 feet from the inside wall of the pool unless they are GFCI protected. GFCI stands for Ground Fault Circuit Interrupter, and it is a device that can detect ground faults and quickly shut off the power to the circuit, preventing electric shock. Lighting fixtures must be located at least 12 feet above the maximum water level of the pool. This is to prevent swimmers from accidentally touching the fixtures while in the pool. Overhead power lines must be located at least 22.5 feet above the pool. This is to prevent swimmers from coming into contact with the power lines while swimming or using pool equipment. When working on electrical equipment near a swimming pool, it is important to take precautions to prevent electric shock. Always turn off the power to the circuit before working on any electrical equipment. Use insulated tools and wear rubber gloves to protect yourself from electric shock. Never work on electrical equipment when you are wet or standing in water. If you are not qualified to work on electrical equipment, hire a licensed electrician to do the work. A licensed electrician has the knowledge, skills, and experience to safely install and maintain electrical equipment near a swimming pool. They can also ensure that the pool is properly bonded and grounded, and that all electrical work complies with the NEC and local codes. Regular inspections of the pool's electrical system are also important for identifying and correcting any potential hazards. A qualified electrician can inspect the pool's bonding and grounding system, check for loose connections, and test the GFCI protection. They can also recommend any necessary repairs or upgrades to ensure the safety of the pool. In addition to following the NEC and local codes, there are a few other best practices that can help to prevent electrical hazards around swimming pools. Firstly, never use electrical appliances near the pool. This includes radios, televisions, and other electronic devices. Secondly, keep electrical cords and extension cords away from the pool. Thirdly, do not allow children to play with electrical equipment near the pool. Fourthly, educate swimmers about the dangers of electricity and the importance of staying away from electrical equipment. Fifthly, post warning signs around the pool to remind swimmers of the electrical hazards. In conclusion, bonding and grounding are essential safety measures for swimming pools. By following the NEC requirements, maintaining proper clearances, taking precautions when working on electrical equipment, and hiring a qualified electrician, you can help to prevent electric shock and ensure the safety of swimmers. Now consider the scenario involving a spa or hot tub in close proximity to the pool. The same bonding and grounding principles apply, but there may be additional requirements depending on the specific installation. Spas and hot tubs typically have their own dedicated electrical circuits and equipment, such as heaters, pumps, and lighting fixtures. Each of these components must be properly bonded and grounded in accordance with the NEC. The metal shell of the spa or hot tub must also be bonded to the pool's bonding grid. This is typically accomplished by connecting a bonding conductor from the spa or hot tub shell to the pool's rebar bonding loop or a dedicated bonding busbar installed near the spa or hot tub. If the spa or hot tub is located within 5 feet of the pool, any metal surfaces within that area must also be bonded to the pool's bonding grid. This includes metal fences, metal door frames, and metal window frames. In addition to bonding and grounding, GFCI protection is essential for spas and hot tubs. The NEC requires that all electrical circuits supplying power to a spa or hot tub be GFCI protected. This is because spas and hot tubs are typically used in wet environments, which increases the risk of electric shock. The GFCI device should be located in a readily accessible location such as the electrical panel or a nearby junction box. Regular testing of the GFCI device is important to ensure that it is functioning properly. The GFCI device should be tested monthly by pressing the test button and verifying that the power to the spa or hot tub is shut off. If the GFCI device does not trip when the test button is pressed, it should be replaced immediately. When installing a spa or hot tub, it is important to follow the manufacturer's instructions and the NEC requirements. The installation should be performed by a qualified electrician who is familiar with the specific requirements for spas and hot tubs. The electrician should also ensure that the spa or hot tub is properly bonded and grounded, and that all electrical work complies with the NEC and local codes. Regular inspections of the spa or hot tub's electrical system are also important for identifying and correcting any potential hazards. A qualified electrician can inspect the spa or hot tub's bonding and grounding system, check for loose connections, and test the GFCI protection. They can also recommend any necessary repairs or upgrades to ensure the safety of the spa or hot tub. In addition to following the NEC and local codes, there are a few other best practices that can help to prevent electrical hazards around spas and hot tubs. Firstly, never use electrical appliances near the spa or hot tub. This includes radios, televisions, and other electronic devices. Secondly, keep electrical cords and extension cords away from the spa or hot tub. Thirdly, do not allow children to play with electrical equipment near the spa or hot tub. Fourthly, educate users about the dangers of electricity and the importance of staying away from electrical equipment. Fifthly, post warning signs around the spa or hot tub to remind users of the electrical hazards. By following these best practices, you can help to prevent electric shock and ensure the safety of users.